excited about hearing about native apps? Sorry about that, that's not actually what I'm going to talk about. It turns out that was a placeholder title I wrote quite a while back, and I actually forgot to send them the update about what it was actually going to be about. Sorry about that. But I'm going to talk about something reasonably related. What I'm going to talk about next is really about making those native apps amazing. How do we make them really great, really well tested? And I'm going to talk about hopefully revealing what I think are some of the secrets to, I'm just going to start my timer, to blazing fast, so rock solid mobile acceptance test. How many of you would attribute the words blazing fast and rock solid to your tests which run against your mobile apps? Good, no one. You're not alone. This is not unusual. This is pretty typical. Before we get into it, I want to quote something here. It's gonna sort of be a theme throughout this. This is a quote from Martin Fowler. I'm sure most of you all heard of. Wrote great books on refactoring and things like that. He termed a type of test that he called the subcutaneous test. Does anybody want to let me know what subcutaneous means? Perfect. It's the layer that just sits beneath the outer layer of your skin. So here he describes a subcutaneous test to mean a test that operates just under the UI of an application, like beneath its skin. This is particularly valuable when doing functional testing of an application. Just to get a definition of tests down, there are really two kinds of tests in the world. There are the tests that verify your code is correct. Often the kind of thing we're focusing on as developers is this code doing the right thing. And we would use unit testing and functional testing to assert that. There's a second type of test, which is probably even more important, that checks, did you write the right code in the first place? There's nothing worse than spending great effort and time writing wonderful code that does the wrong thing. So those kinds of tests are what you might call acceptance tests. They're the things that guard and guarantee that what you think you're doing is in some way bringing some value to the customer. That could be ways to save the money, make the money, or just bring joy and delight to a customer or user. Those are the things that really matter. Here I've got now the world of testing is full of terminology, and often terminology that's interchangeable, and it's often very hard I could be saying one thing and talking about functional testing, and I'd have an idea of what that meant, and you'd have a completely different idea about what that meant, and this lack of ability to sort of just share a common understanding of this terminology is quite difficult. It's like speaking two different languages, which doesn't often help. So here I just want to focus on, there's a whole raft of them here, which is an attempt to sort of try to create some sort of definition around these things so that there's less confusion about it. The one we were going to focus on in the context of testing mobile apps is acceptance tests. Can anyone spot the one thing that acceptance tests do that all the other tests beneath it don't do? I'll just point it out. It's this one here. It's the only kind of test in the entire suite of all of them that test the business or customer expectations of what the software does. So it's kind of important that we have some of those. Now, most of us, TDD and unit testing has been very prevalent. This is something that most people have come to accept as a good thing. But I think this type of testing is a little bit still murky. We're still yet to really sort of get a strong understanding or feel for what this is and how to implement it. And certainly that's definitely the case within mobile. Mobile being such a new industry, only 10 years old compared to the rest of this industry, which has been going for a lot longer. We're still figuring stuff out, and I think this is one of the things we're still trying to figure out. Now, one of the problems of test-driven developments, if I quote Ken Beck here, he says one of the weaknesses of it, as originally described, is that it can devolve into a programmer's technique used to meet a programmer's needs. We get in our own little world. It's all about us and our little bit of code here. But with acceptance testing, there is no ambiguity. This is a technique for enhancing communication with people for whom programming languages are foreign. So that would be other people within a business or a team that need to be involved in the development of that software, but who don't necessarily understand code. Why is this important? It's important because You have a manager or a boss or somebody at the top of your company who is kind of paying the bill for this thing. And they're doing that because they think there's something great that can be done. But they're very busy people, and they don't have time to worry about all the details. They just kind of set some kind of vision and then they disappear and then appear 6 months later asking where it is. The next problem you have, there is all the poor developers and teams and everybody who's meant to kind of figure out what this guy or lady at the top wanted them to do. And their complaint is always, they can't even tell us what they want. They don't even know what they want. How many of you have ever felt like that in your teams? I'm seeing all kinds of smiling faces out there like, I recognize that. And then the poor customer at the end. What a terrible app. What a piece of... thought this was a good idea. And so the problem is there's this huge void between the initial kind of idea and concept and vision and the team that then have to go and implement this. They don't have much time for all the details. So this is an axis which describes the amount of level of understanding of the detail that's required. Very low down here, but super high up here. He doesn't really care much about the ins and outs and the specifics of anything, but because we've got to work with computers, and computers are the dumbest things on the planet, who need explicitly every single little thing explaining to them before they can do anything, or they'll just sit there doing nothing at all. The poor developer has to kind of encode all this in some weird and wonderful language to tell that computer what to do. So he needs immense amounts of detail. And there's this huge void, and we spend most of our time agonizing about how to get from here to there. If only we knew how to get from there to there, we'd probably end up doing a better job. But it's interesting as well, the user doesn't really care about all the details either. You think about, I'm an Apple fan, so Apple products, it just works. The amount of details and decisions that have to go into that feeling of you don't know how all the things that went into making it, but it just feels right. It just does the job. But you don't know the details of that particularly. So this is a really important time in terms of getting software correct. This is where the kind of acceptance testing type stuff would come into. And to back this up, the other thing I think that I heard this, I was at a hotel, went to Greece in Athens, and I went to a hotel, and they had this up quoted on the wall, and I'd never heard this, but I didn't know this guy had said it, but I thought, what a wonderful summary of what we're trying to do. Well begun is half done. You start off well, things tend to go well. You start off badly, it's very hard to undo and pull it back. So it's worth spending effort at the beginning to understand really what is wanted and needed there. So how do we do that? So I'll take the mobile example. Now, mobile software is complex. It's getting more complex. Your apps are wonderful things. They appear amazingly simple, but behind that, there's a ton of complexity going on. So how do we try to capture all this complexity and all these requirements? Now, I've worked in mobile software development myself, and over the years, I've seen quite a lot of times this as a means of describing the requirements of software. A wireframe. Anybody use wireframes to describe the software? These are so lacking in detail, it's unbelievable. They describe what it looks like, but it doesn't tell you really anything about what's happening, so it's very, very difficult to implement a piece of software from just drawings of what the software looks like in various different states. It doesn't tell you anything. Some people will try and draw a flow chart and put words on it to try to make up for the lack of detail in there. But it still is a very poor job at describing all the ins and outs of what needs to be done. So because the detail is lacking, we're left to kind of make assumptions, make things up, try our best, and then that's where we find out later that's not really what we meant. Now we've got new stories that we need to introduce, or bugs that they're not even bugs. Sometimes, a lot of the times, it's just we did the wrong thing because we didn't fully understand what the requirement was. So what are some alternatives to this? Well, how would you even test this? If that's your specification, the only real way you can test that, if that's a specification, is by trying to test that those specifications meet the piece of software you've got. And so in mobile testing, we've had a wonderful sort of spectrum of different technologies come and go over the years. You will be familiar with things like, if you're old enough, been in this game long enough, things like Zucchini and Calabash and Frank and Kif, all wonderful names. How many people have heard of those things or experienced those things in the past? No one. Okay, so maybe we're not even doing any testing at all. These were all attempts to sort of provide a way in which you could test the software from the perspective of the user, basically based on automation tools. UI, basically taking the job of a QA who's pressing buttons and trying to make a computer press buttons instead. The typical kind of, way things tend to go. Oh, it's costing too much and taking too much time to have humans pressing buttons. Let's get some computers to press buttons. Turns out computers are really poor at doing things that humans do, but really good at things that computers are good for. If you know much about kind of the definition of what would make a good test in unit test, certainly that we use this acronym of FIRST, which is the fast, independent, repeatable, self-validating, and timely. If you try to sort of measure automation tests or UI tests against that set of things, it's a huge fail. They're certainly not fast. They're certainly not done timely. They're fragile as anything, and very difficult and very complex to maintain. So the one thing they're meant to do is to provide confidence in our software. They end up being we have so little confidence in them because they take so much effort to maintain and tell us very little that we don't get very much at all from it. So you have to question how much value is there in testing it this way. And I did this talk at a conference last year, and someone smarter than me was doing a talk, and they said this, and they captured, and I thought, that's always the thing that I've never really fully understood why this is such a problem, but I think he caught this brilliantly, and he said, throwing robots at a human interface may be the common sense approach, but it puts robots at an immediate disadvantage by forcing them into our human world. Humans are amazing at dealing with changes in UI, and if the flow changes, we just figure it out and move on, and we learn very quickly the new thing. A computer just stops. So I don't know what happened. The button moved. That's it. I can't do anything more. We have to go fix it. So this is why it's so problematic. And we know it's really problematic and expensive because for years people have been talking about the testing pyramid, and always at the top of it is UI or full stack integration tests, which is what UI tests end up being. Why are they problematic? Because they're immensely slow and they're immensely costly to maintain and run. So we only have very few of them. I'm not saying you wouldn't have any at all. You do have some. They have a role. But their role is not to exercise all the important details of your software and all its business logic, because it simply would be too expensive to do and far too slow to give you enough feedback quickly enough about whether you're still doing the right things or not. So this service level in the middle, I think everybody gets unit tests and everybody gets UI tests. And then you get to the bit in the middle and everybody just goes, I don't know what that is. Not sure how to implement these things in the middle. And it doesn't help either that every time I see this diagram, it has different words for all the different parts. So it's like the terminology is also, again, mixed up. So you talk about service and people will have one idea of what that means. You talk about acceptance tests, other people will think something else of that. But here's how I would like to think that a great acceptance test for apps would be. How might we make great acceptance tests for our apps? What would be the definition of really good acceptance tests? So I think if they were written by business and QA with sufficient detail, that would be amazing. It'd be like, it wouldn't be my developer's perspective on this. They'd be written by people who really understood the problem far better than I did. If they could be viewed and understood and run by anybody as well within the team, again, not just engineers or QA, that would be cool. Everybody would kind of own the problem and have a common understanding of what we're trying to do, which would help to alleviate misunderstandings between people in the team. They really should not be brittle. They should not fail all the time and be really difficult to kind of keep working, otherwise we don't get any confidence from them. So they really can't rely on the UI, because the UI is the most fragile, most brittle part of your application. It's the bit that changes probably the most after you've kind of established the core functionality of the software. You know, it's subjective, it's subject to redesign, it's subject to whims, it's subject to user feedback. It will constantly be changing and evolving, probably more quickly than the actual core business logic of your application would. They'd be comprehensive. They might include examples to help us understand what the requirements are, and they'd be blazing fast, and you'd run them all the time. You wouldn't run them overnight. You wouldn't run them once a weekend or once a month. You would run them every time you did an integration and a build, because they would be fast enough that you could do that, which meant you would immediately know if you're on track or if something's gone slightly wrong. So I read all stuff about what tests should be, and I was working on teams where we were testing all our mobile stuff through UI stuff, and it just had none of these characteristics, and I just thought, this doesn't seem right. This seems like we're doing something horribly wrong here. Why do we have such an over-reliance on using UI tests to do everything? So I kind of referred back to some things that, I'd read various books over the years. And I remember kind of certain references to things like in Extreme Programming Explained by Kent Beck. And there was another book that I'd heard of but never read, which is called ATDD by Example, which is Acceptance Test-Driven Development by Example. And another one called User Stories Applied. And I went back and looked at some of these books to try to sort of figure out, well, how would these guys do this? What would they do in this situation? And they all made references to sort of using, acceptance testing and definitions and using various sort of different tools and things to do this. So I took a look at one of the tools that were mentioned. Now the times have moved on and we have more tools that are availability these days, familiar with things like Cucumber and those types of things. But the one that was mentioned here, and I thought I'd give a try, was something called Fitness, which originally came from a project by Ward Cunningham. Does everybody know what Ward Cunningham did? What did he make or come up with? I can't hear. Yeah, he might have done that as well. He actually invented the wiki. So if you use a wiki at work, this is the guy, that was his idea, and then it went on from there. So he built this, and he sort of started out and saying, great software requires collaboration and communication. I don't think anybody argues with that. And he's like, this is a tool that could help people enhance collaboration. And the way he did it was really really interesting. He did it like this. You can see how long ago this was by the screenshot there. I don't know what version of Word that is, but obviously the screen size was only that big. Probably far smaller than your phone is today. And it's a Word document, and it had some description of what the kind of feature was, and then it had this table, which was a new feature in Word you could do. You could put tables in Word. It was kind of mind-blowing at the time. And there were some examples here, so here's some kind of actual examples of what this story says, and then there's some results at the end that should be true. And then he somehow, I don't know how he did this, he figured out a way to sort of script this, so he could use this tool that he'd built so that it would actually color in the table cells with whether the software did what that thing said or not. So it would take the inputs and then the expected outputs and then color in the Word document with the results. So you would get a test report in your Word document that was written by the product owner. It seemed really cool. Seemed like that would be a big thing and everybody would be doing that 20 years later. That would be how everything was done, but hasn't quite happened that way. So some other guys then came along after that and said, that seems like a nice idea. And then the wiki had been invented, and they said, maybe the wiki would be a better way instead of using Word documents to do this, because you can distribute that and everybody can see it and use it in a web browser. So these guys, Mika Martin, Robert Martin you probably know, is more familiar with, the author of Clean Code, those things, and they went away and built this thing called Fitness. And I looked at this and thought, okay, this is cool. I downloaded it, tried it out. It didn't really work with an iPhone just yet, but I figured maybe there's a way to make this thing work. So, I asked myself the question, would these two things blend together? Would this thing Fitness from, I don't know when, the mid-2000s, something, it's a long time ago, it's been around a while, and the most modern thing you can think of, which is the iPhone, could we smash these two universes together and see if we could get these two things to work together? So I did, and I spent some time working on it, and we put it on a team we were working on, and the team kind of all embraced it, and we figured out how to get the whole thing to work. And I'd like to show you a demo of the end result of that with an example. So what I would like to show you is an example of a game you might recognize. Do you call this Noughts and Crosses too? Tic-tac-toe, you use tic-tac-toe, okay. Noughts and Crosses in the UK, I don't know, that name never stuck. So let's play a game with this and watch this. So what I'm going to show you now is a video of a demo of this game. I'm sure you know how to play this game, but just in case, here it is. And I think I have to tap again. There we go. So here's our UI for the game. You can play against the watch, or you can play against another human. Probably no surprises about what happens in this game. I'm sure you all understand the rules. But what you're actually watching here is somebody test the app. This is a human being testing this app. Now, does anybody know how many variations, how many different ways there are to win a game, or how a game of tic-tac-toe can complete? Any statistical people here with bigger brains than me? No, it's a lot. It's a lot. It's in the hundreds of thousands, I think. So there's an awful lot of things that you would have to do to actually have confidence that this piece of software actually works. And doing it this way manually You would never do anything other than 1 or 2 sort of, smoke tests of this because it would just be take way too long to do it with a human being. So the next step a team might go is like, well, it's taking far too long to do it with humans, so let's get computers to do it because computers are cool and they don't ask for very much money and they will work overnight without grumbling at all. So let's just throw a bunch of them at the problem. So you do this and then you use some of these tools to kind of automate the UI. And it looks very cool. People love a demo of this. They're like, wow, it's like a sort of computer doing this. Isn't this amazing? So I'm running the test now in Xcode. It's going to launch it, and you're going to watch a computer play tic-tac-toe and test that this game still works after we've done some further development on it. Interestingly, you'll see it's having to run it on an iPhone because we can't do automation testing on a watch, so we have to use the iPhone version of this to prove it. And it's going through, so we got the first test is finished, now it's running the second one. Second one passed, it's running the third one. Timed this as well. Still, here it is. Okay, woo, test succeeded. Anybody see what was wrong with that? How did that feel as a sort of waiting for it to complete its games? Just super slow. It's like 10 seconds per cycle. It tears the app down, it gets rid of everything, and it brings it all back again to try to sort of make it independent so there's no state left around. It's not going to screw up your later tests. But all that time taken to install it, launch it, wait to get to the screen, press the buttons, very, very slow. So, this is as good as it's going to get. This is Apple's implementation of UI testing. They know how this thing works inside out, so it's never going to get any better than this. And this is their best, running on the most recent MacBook Pro you can find. Still takes that long to run 3 tests. So we're still nowhere close to being at a sensible place in which we can go through all the variant ways of having to play this game in a sensible fast. It's certainly not blazing fast, nowhere near. So let's try to deconstruct how you could test this differently without having to press buttons on the screen. So this is the game. If you strip it back, you've got a grid. A grid could be ordered, positions on that grid could be 0, 1, 2, 3, 4, 5, 6, 7, 8. So you could describe any position on the board in this manner. So you could actually take an input to a piece of software and say, if I give you an array of numbers of 0, 1, 4, 2, and 8, and assume that's a 2-player game going backwards and forwards, that would result in this game being played. 0, 1, 4, 2, 4, 8 in that order. And that would be the end result. You would have a diagonal winning line for player 1. So that's a game of tic-tac-toe that you could feed into a computer to play. And if you stripped all this away, you could represent the result of this game, not through a UI, but through a simple transformation of that into another array, which is, well, we've got the naught, cross, cross, nothing, naught, nothing, 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 naught. Ta-da, we've got we can represent a game like that. That would be the output from the system. And that might actually be how the code is written, right? The code might actually be doing something very similar to this, where it's taking inputs like that and sending outputs out like that, and then some view controller somewhere is converting this into something you can see on the screen. So if you could talk to your software at this layer and not the layer of the UI, the subcutaneous layer here, these inputs and outputs would be super fast because you wouldn't have all the slow UI stuff getting in your way. You could do it like this. So people familiar in this industry will probably be familiar with the more fashionable way of doing this, which is to write things like this. Totally fine. If this helps understanding of the problem space, not a problem at all. Although I would sometimes challenge the value of all the words. There's a lot of words that need to be written, and the only important bits are really the input and the output. So you could really strip and condense this back down to something much more concise, and still, I think, completely readable to any human being working in software development. We work in spreadsheets and Excel all day long, most of us, and this is just a simple, here are some turns, here's what should happen at the end of it, some input and output again. And because it's nice and condensed, it doesn't take much to have lots of variance in that and be able to see all those without, again, all the words, which mean you end up with text files this big. And again, if we saw as how Ward Cunningham did it originally, if you could take that specification and just see it light up green, if it worked or not, that would be kind of cool. And if one of those went red, you'd know exactly what the problem was, and you'd be able to go and look at that and investigate it. So I'd like to show you a demo now of taking this approach, using fitness and using it to test the watch application at that subcutaneous layer, and just give you a look at that. So what's the first thing we're going to do? So we've installed fitness, and we've defined the rules of the game in here. We've used a table like that to describe each game, and we're going to hit test. Now, we haven't yet implemented a piece of code which actually joins this up with the actual iPhone code. So I'm going to switch to the software, and this is a simple bit of code which basically binds the two together. I'm going to fix the bug in there, which meant it wasn't working, and then we're going to hit the test button again. And all lit up green. I'd like to focus on the time that took to play all those games, sub-seconds, so nice and fast. Most of that time is actually waiting for the app to launch. It's not the actual execution of it. So I think it's fair to say we got blazing fast from incredibly slow, very, very nice. So I ticked that one off on my list of acceptance criteria that I wanted to get to. Next, what about fragility? Because fragility is a big problem. Will it suffer the same problems? So let's do something here. What am I doing? Okay, so all the tests were passing the UI tests. We've got a new requirement comes in, which is, we want to put a screen at the start of this flow which says new game, because we think the users didn't quite understand that. So we just want to change the design a bit. We've had some feedback on that. So we're going to introduce a new screen. We're going to put a button on there. When they click that button, they're going to get sent to the actual game screen and start playing the game. So the game itself still works completely fine, as you would expect. So as a human, I can play this game. I can get through that problem. Didn't get to the screen and go, oh no, I don't know what happens now. It's like I hit new game and I moved on and I carried on. So users are going to be perfectly happy. So what we have is a perfectly good functioning application. We should ship this. But when we wait for the test to run overnight, we get back in the morning, this is what's going to happen. And we wait overnight for the test to run. Anyone want to take a guess what's going to happen? Shouldn't be a surprise. Failed. They're all going to fail because the computer just can't figure that out. So now we've got to go in and fix the test and tell it, there's a screen you've got to press the button on now. And lo and behold, if we end up putting login in this thing, they'd have to log in every time to see this code, and it would take even longer to complete. So our tests here are still fragile, but let's go and check the acceptance tests and see how they're faring. The same test, no code changes, they still work. Because they're not subject to having to flow through the app to get to the place, and they're not concerned with pressing buttons or any changes to the UI, because they're sitting at a level beneath all that stuff and talking directly to the system through a set of APIs. So I think it's fair to say that they're rock solid as well. Certainly more rock solid than the UI tests are, which are immensely fragile. So hopefully that to you would be an interesting, better way to approach testing. It could be any app, but I think certainly mobile apps would suffer greatly from this sort of over-reliance on using UI testing for really everything. And the real secret to this is, and I didn't really appreciate this the first time I tried this, but the real secret to this is that you need to have a good architecture. You need to have a good software architecture to make this work. It's very difficult to make this work if you don't really have a clean way to separate the UI part of your application from your core sort of business logic for your application. So architecture is really something you need to pay attention and focus to kind of be able to do this. So architecture patterns cleanly help you separate details such as UI, databases, and networks from your core business logic, allowing you to independently validate your system without all the slow, horrible details of things like networks, databases, and the UI. I want to give you a quick look at the architecture of what that actually means. The important bit here is that we've got a sort of nice boundary between our system and then everything that kind of is on top of that. So think of this as the subcutaneous layer. And that what we want is our tests to be able to come in and talk directly to that without having to go through all this here. And so there's a nice mirroring of actually the way the architecture of this thing works to achieve the thing we've just seen, which is that instead of a human pressing buttons on an OS that send events into your views that then sell to your controllers, we've just swapped that out and put in instead acceptance tests driven by a CI system, which talk through a socket server that goes into some fixtures, which is that little piece of code I changed, which then delegate instructions in and then get answers out, and they just flow back out to the system. And that's how you achieve that ability to just bring one thing in and take the other thing out. There are lots of software architectural patterns. It's beyond the scope of this talk to get into them. But all of these will help you do this. They will all talk about this separation of concerns and responsibilities. So any of these would be a helpful thing in terms of being able to do this. And if you're already following patterns like this, you're probably most of the way there to being able to adopt a sort of this sort of acceptance testing pattern. So what have I learned about developing for mobile? Well, I've certainly learned that fully understanding my requirements early saves me lots of effort later. It just does every time. There are things which happen later down the line which are just like, oh, if we'd have just talked about that a little bit more and figured it out, we wouldn't now be having to rework that and undo the work. And this has become more and more important because as I've learned and understood the importance of building quality into the software you're building and using practices like test-driven development, you're putting more quality into the work that you do. So there's kind of nothing more wasteful than putting really lots of effort into building very high-quality software that does the wrong thing. It's worthless if it does the wrong thing, so it's a great waste of time if you're not getting the requirements early correct. All my experience tells me that UI-based testing is basically flawed. It is not a solid foundation on which to base your testing strategy. It has a place. It is useful for some things like strategic tests just to check the plumbing of everything and check a flow through the application works. I'm certainly not saying none of it at all, but we know because they're so expensive and costly that you don't want to have a huge amount of them. So using it for everything and testing all the business logic of an application is probably not a good thing to do. Architectures are essential if you're going to make this work. Otherwise, you can end up in, even with this approach, you can end up in a bit of a mess if you don't have a clean architecture approach to be able to sort of separate the view stuff away from this. I think the whole thing is a very helpful technique for if you're working on complex long-term software projects with a team. For a one-man band, unless you're a weirdo like me, you probably wouldn't need to do a lot of this stuff. But I kind of like the whole sort of process of this, so I would do it myself. But probably has a lot more value on a large team with some critical, important stuff that you're doing. So, what software is complex? Well, I think I've already said it. Mobile software is complex. I think it used to be considered to be something slightly trivialized as some sort of front-end thing. It's a bit like building web pages. It's really not that difficult. But anybody who I think who's involved in it will understand that this is not trivial at all. We are building desktop-class software on ever more powerful hardware, being asked to do even more complicated things. Just imagine the complexity that there is in something like Uber or something like that. It's just insane what needs to be done. And introduce the fact that we've got multiple platforms, multiple devices, all kinds of environmental hazards like networks that can just disappear. It's extremely complicated stuff. And in the life cycle of mobile, we were kind of here for the first sort of 8 years or so, but at this stage, we are all the way up here in terms of the evolution of this industry. We have legacy software now. We're not running greenfield apps most of the time. We have billions of customers using these applications. We have businesses which depend on the success of these applications now, given that's where consumers want to consume services and products. So the questions now are far different to what they were earlier in terms from an engineering perspective. I think it requires more discipline and rigor around the way that we build that software. Because what's coming next is, this is only getting more difficult as time goes on, because we're only just getting started. There are technologies coming down the line now, so rapidly evolving, and who knows in a year or two's time what else is going to be there. So this is not getting simpler, it's getting more complex over time. But thankfully the tools are getting better, and I think we're getting more mature as an industry anyway, so that's going to help us along the line. So I think that's it. Thank you very much for listening.